Hello and welcome to the Algebra Practice Work Sample Review. I just want to look today at a work sample problem based on algebra material. Most of the time whenever we see an algebra practice work sample, I guess the most popular area of content for this would be a system of equations problem. And so let's go ahead and read this problem and see what's going on. It's about a music download. Sally wants to purchase an album on iTunes. There is no discounted price for buying the entire album in bulk, so we're going to have to buy each song individually. The songs are sold for 99 cents and $1.29, and there are 26 total tracks on the album. So if buying the songs individually will cost a total of $30.84, how many of the tracks cost 99 cents, and how many of the tracks cost $1.29? So let's just talk about our basic strategy here. So our strategy, now this would be something that I wouldn't necessarily put on my work sample. This might be on my scratch paper or something like that. I need to build my two equations. So I need to build those two equations. I need to figure out, what the two situations are going to be. And in fact, we're gonna have this idea of the total tracks as one equation and the total cost as the other. So that's kind of the important part. And then when I'm building my two equations, I'm going to have to figure out what are my variables. And you may or may not know what the variables should be at this point. But if not, you're going to learn. Okay. Usually the variables are going to reflect what's being asked in the question, because that's kind of what you're looking for. Now, in this one in particular, we're dealing with songs, and we're buying those songs. Let's go ahead and look at the completed work sample and sort of go step by step through that in order to get a better understanding and not have to wait for me to write everything down. So this one is the one that I've completed. I'm going to sort of block parts of it off so that we sort of go through step by step here and understand what we're looking at. Okay, starting off with the important information. Okay, what's important to this problem? There's 26 total tracks. Okay, some cost 99 cents, some cost $1.29, but when you add up those costs together, you're going to get $30.84. Okay, this is a good scenario, or a good way to express what you're looking at, and this is totally acceptable in a work sample. Remember, not everything has to be writing things out in words and in paragraph form. It can be more of a visual than that, and this is something that you might see more in a textbook. Trust me, when I was going through math in high school, I thought I'm never going to write stuff out like this, but once I got into college and even later in high school, I realized that it really does help you set things up. So when I look at the first equation, it says 26 tracks lead us to this equation up here, where I'm looking at the number of 99-cent tracks and add that to the number of $1.29 tracks, and that's going to be my total tracks. Down here, the number of 99-cent tracks times the cost of a 99-cent track, kind of redundant there, added to the number of $1.29 tracks times the cost of a $1.29 track, yeah, again redundant, is going to equal the total cost. So let's sort of look at the things that I know from the problem. Well, I know the total tracks. I know the cost of a 99-cent track. How much does that cost? Well, 99 cents. I know the cost of a $1.29 track. That's $1.29. And I know the total cost. And that's $30.84. Should have set up here. The total number of tracks is 26. So once you build those models, and maybe you knew when you were building those models and maybe you didn't, but when you do it this way, it shows you exactly what your variables are going to be. Okay, the variables are going to be the ones that you don't know, and they happen to match up real nicely there. And that's kind of explained below, where we're saying we're going to let x equal the number of 99-cent tracks and y be the 129 tracks. Okay, and here I go into that statement that I made. Obviously, and you never really want to say obviously, but 99-cent tracks cost 99 cents, and 129 tracks cost 129. Okay, so then we get our two equations from that. X plus y equals 26, and 0.99x plus 1.29y equals 3084. So now I have my two equations set up, and you have a bunch of different ways that you can solve a system of equations with two variables and two equations. And it's up to you at this point to pick which way you want to do it. Let's look at how I did it. We're going to look at the whole thing here. So I clearly state that I'm going to use substitution. That's not a bad thing on a work sample. Okay, I'm going to use substitution, and maybe before I went through all this, maybe I actually solved it on my scratch paper just to give me an idea of how to do it. Okay, so I get x by itself. I'm solving equation 1 for x. Okay, and I get x equals 26 minus y, or negative y plus 26, either way. Plug that new equation 1, plug this into equation 2 for x. And then I'm going to solve that new equation 2 with that plugged in. Okay. Now, keep in mind here, I'm not going through writing every step, distribute, combine like terms. I'm not doing all that. That's not required. As long as you say what you're doing, and you can do it if you want to, it may lead to a better score in the communicating reasoning part, but it's not required. You can totally follow the train of thought that's going on here without having to do all those. But do notice that instead of just going from this step to 0.3y equals 5.1, I'm actually showing that I'm subtracting that 25 like you did when you started solving equations. Okay, that's kind of important. Excuse me. And then notice we get y equals 17. And step 4 over here, use that result to solve for the other variable. Okay, we're going to plug it into one of the equations that we had before. I'm plugging it back into this equation, so I'm calling that new equation 1. If you wanted to number all these different equations and say plug it into equation 3 or whatever it would end up being, that would be okay too. So then when you plug that in, you get x equals 9. And it's not enough just to say that x equals 9 and y equals 17. You have to put that answer back into terms of the problem. Okay, and that's very important for the accuracy. So Sally bought 9 tracks that cost 99 cents and 17 tracks that cost $1.29. We're done, right? Not quite. That was just the first run through of the problem. That was, taken care of. If I'm looking at scoring this, up here we're kind of looking at them making sense of the problem. Okay, and that would be a pretty good score there, maybe a 5 or 6. Translating into equations, and this part is kind of the representing and solving, as well as it's also the communicating reasoning, and it's leading to the score of the accuracy. So you can't really just say, here's my making sense of the problem. Up here, here's my representing and solving. Here's my my accuracy. You can't do it that way at all. Just solving the problem itself is going to lead to all these different scores. Okay, and so yeah, that takes us all the way down through accuracy. Then my best advice is always flip the paper over and do the problem again for your reflection. Okay. And here I get a little bit long-winded, which I don't really recommend, but if you want to be sure that you know what's going on, you can definitely do that, and it can lead to a little bit better, but more words doesn't always mean a better score. Okay, so for the reflection, there are 2 types of tracks that Sally bought: tracks that cost 99 cents and tracks that cost $1.29. The total number of tracks that were bought can be found by adding the two types of tracks, the 99-cent and the $1.29. The total number of tracks that was bought was 26. Thus, we let X be the 99-cent tracks and the 129 tracks be Y. And we get our new equation 1. So notice I'm going into very gory detail here on how I'm getting my equations. That is imperative on the reflection. If you don't talk about your equations again, you won't pass the reflection. If you just assume that your equations were true, that's not going to get you a good score. Okay, so the total cost was $30.84. This can be found by multiplying the number of 99-cent tracks by 99 and adding that to the number of 129 tracks by 129, resulting in the equation 2. And then if you notice, I talk again about what I'm going to do. This time I'm going to use elimination, okay? And I tell you that I multiply that equation 1 by something in order to get it set up to eliminate, okay? And using the step numbers kind of helps the flow of the problem. Okay, notice in the first one, or the front side, I kind of went straight down and then back over and straight down. Here I'm going here, 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 here. Labeling your steps helps make that clear. Okay, but just using elimination, if you need a refresher on that, you can always ask a teacher and they'll help you out. Okay, but using that elimination strategy, I get the same answers and therefore my problem's done. Some, big places that people mess up on, as I mentioned in the reflection, not talking about where they got their equations. Excuse me. Not talking about where they got their equations is a big part where people get caught up on. And honestly, not doing the reflection is a very common problem. If we go to the front looking for other sometimes common mistakes, this part right here, not letting people know what their variables are, that's very important. That's called defining variables. You always want to define your variables. Don't use X and Y if we don't know what X and Y means. Okay. And other than that, usually people are pretty good on the system of equations stuff. But another place that people mess up on a lot is right here. Okay. Putting the problem back into terms, or putting the answer back into terms of the problem, instead of just saying X equals 9 and Y equals 17. You need to say what that means for the problem. Alright, so that's that. I wish you very good luck on your upcoming work sample, and we'll see you later.